But yeah.
Good day, listeners. Welcome to my channel, H Online Science Tutor, where of course we'll be learning science practicals and demonstration of sciences. In today's video, we'll be learning physics, and to be specific, we'll be looking at general introduction to physics practical. Okay, generally speaking, physics practical is divided into three. We have data collection, data analysis, and of course some theoretical questions that comes after the practical. Starting with the first one, which has to do with data collection. Of course, in this part, students need a lot of apparatus which they are going to put together. Either they connect them together or they arrange them one on top of the other for them to collect the data. And then most importantly, the student requires some measuring instrument which they are going to use to take readings for the collection of data. Okay, so all the apparatus which they are going to either arrange or connect together with measuring instruments will make the student to collect data. And while doing that, there is going to be a particular quantity which students will be required to change in the course of practical. So as they change that very quantity, the readings which they are going to get will be changing. Okay, and the students will note down all these changes, in the quantities that is being affected. So this is the first aspect of the physics practical, the data collection. Okay, of course, data collection is the simplest as far as the three branches of physics practical is all about. Okay, why I said it's the simplest is because the student will be guided enough. There is two-way guidance to this data collection. Thus, the student will be guided diagrammatically, and at the same time, there's going to be instructions which students are going to use. Data collection part is the easiest, like I said, even though most students complain that it is very difficult, they can't do the practical these days. Okay, left to me, the data collection part is the simplest. Why? Because the student will be given enough guidance on how to conduct the practical. Okay, there's two-way, there's double guidance for students. The first one is the diagram, and the second one is other instructions that follows the diagram. Okay, so the diagram alone is supposed to be enough for students to conduct practical. But because the body conducting the exam, we want to simplify the work enough for students. They will give them the diagram, and at the same time, they are going to give them instructions to further explain the diagram. So, if these two are given, I think any student is supposed to be able to carry out the practical, because enough guidance has been given. You have the diagram, you have the instruction. This is an example of what I'm referring to. So these are practicals. These are 3 different practicals on physics. So we have this section to be the diagram to guide the student, and apart from this diagram, we also have further instructions to further guide the student. Okay, so with these two, I think students should be able to conduct the practical. This is another one again. You have the diagram, and at the same time you have the instructions to further guide the student. So this is another one, the diagram and the instructions to guide the student. So I think students did not have any excuse not to be able to conduct the practical anymore, because these are more than enough instructions that has been given to students. Okay, the only thing that student needs to bear in mind as far as the instruction is concerned is the diagram is coded. There are symbols that are used to represent the physical devices in which the students are using. They did not represent the apparatus the way they are in the diagram. It is the only complaint that I think students can give, and they don't know the meaning of what the diagram is representing. But any serious student that knows what he or she is doing, we put in more effort to know what every symbols in physics practical represent. Okay, so in physics practical, symbols will be used to represent the apparatus. So it's left for students now to know which symbol represents which apparatus. Okay, like we have it here now. We have it here. So in this diagram, for instance, now this line that we have here, together with this shaded, together with this bent line, represents mirror. Okay, students should know that. Okay, and then all these points P1, P2, P3, P4, all these points represent the position of the pins. Okay, so this is just the only little difficulty that student can encounter. That's to be able to recognize which symbol represents which apparatus. Okay, but all students should bear it in mind. No diagram will represent the apparatus the way they are. So it's left for students to go and know what symbols represent what apparatus. Okay, like we have it in the second diagram here. Okay, this is a symbol. It represents standard ohm resistor. Standard ohm resistor. Okay, in my subsequent video, we're going to learn more on this. Then we equally have this representing the galvanometer. We have this representing the resistance box, and then we have the whole of this. We have the whole of this representing the meter bridge, and so on and so forth. So these are what the examination body does. So they represent the apparatus which students are going to use with symbols. And part of the effort that students will make is to know which symbol represents which apparatus. So once students can know the symbols and what they represent, then they can carry out any practical. Okay? Because like we have this diagram here, it's telling us that this resistor will be connected to the galvanometer, then the galvanometer connected to the jockey, and then where the connection branches to the galvanometer, we are going to have another connection which will be connected to another standard ohm resistor, and later to resistance box. By the time we get to electricity, we're going to explain this more. Okay, but the point I want to make here now is that in any physics practical, students will be guided with diagram where apparatus will be represented with symbols. No physical apparatus will be represented the way they are in this diagram. Okay, so it's symbols that will be used to represent those apparatus. Okay, I think subsequently we are going to explain this in detail by the time we start each of the practicals. Okay, so that's the way the data collection is all about. So students will be made to connect or arrange apparatus according to instructions that will be given to them, and then part of the apparatus will be measuring instrument. Any physics practical whatsoever will have measuring instrument which students are going to use to take measurement. These are few of measuring instruments that we have as far as electricity is concerned. Here we have galvanometer with symbol G at the center. Here we have ammeter with symbol E at the center, and here we have voltmeter with symbol V at the center, and then we have a meter rule. So I will have a beam balance, a spring balance. So all these, they are few out of the measuring instruments which students are going to use in conducting this practical. So these are the measuring instruments which they are going to use to take readings from their practical. Okay? So as they are conducting the practical, they will be varying some quantities and using these measuring instruments to take changes in their measurement and then get them recorded. So at the end of data collection, students are going to come up with a table which will comprise of all the data which they have to take in the course of conducting the practical. So there's going to be a video on how to make a table later. By the time we get there, we'll explain more on how to make table. The table is what marks the end of data collection. Okay, so after getting the table now, it's now time for students to go to the next part of physics practical, which is data analysis. So it's time now for data analysis. Under data analysis, students are going to plot graph. They are going to find slope. They will find intercept. They will do evaluation, and so on and so forth. So all this falls under data analysis of physics practical. At the end of all this, students will state precautions to guide them from error while conducting the practical. So this is the second aspect of the physics practical. So there's going to be detailed video on this one. So that's how to plot graph. And I know most students they have problem on choosing scale when it comes to plotting graph. So there's going to be video on all these aspects later, which will explain all this in details to students. Okay, so data analysis is all about all this plotting of graph, finding slope, evaluation, intercept, and so on and so forth. Then precaution. So this is the data analysis. And finally, after the whole practical, there's part B of practical, which has to do with theoretical questions. I think almost all the examination body does that. They give students questions, theoretical questions to solve. Okay, so these are all what the physics practical entails, be it in YA, NEPO, NAPTEL, and so on and so forth. Okay, then physics practical has branches. As we have it on the board here, it can be on light, it can be on electricity, it can be on heat, it can be on magnets, and so on and so forth. Okay, like I said in my previous video, the most important one that every student must know is this electricity. Okay, the reason is because questions comes out almost every year on electricity. Okay, so it has to do with electrical devices. The apparatus that students are going to use for electricity are electrical devices, so they are going to connect them together and then take readings from them. So question comes out here almost every year. That means any student that knows what he or she is doing will familiarize himself or herself with electricity, because the no question will come out there. While the other aspect is likely that question will come out, or the question will not come out. Okay, the light too, question comes out there often too, and then the same thing with magnets. Okay, so we are going to explain them in detail too. So we have practicals in which we are going to do on all this, so that students will understand all these branches later, and at the same time they will understand physics practical better. Okay, so having said this, I think we are going to start with practicals on light. The next video will be practicals on light. We're going to start from there. We start from light, then we'll move to electricity, and finally we look into magnets. So if students can understand this, so the students will have better understanding of physics practical. So stay tuned for the next video. Thank you for listening.